Hi everyone, my name is Fatima Nafa. So in this talk, we're gonna introduce the using of large natural language models to convert text to graphical, which is the images. So as an outline for this talk, we will go over the introduction and some related work that connected specific for this implementation, and then problem specification, scope of the study, what we have been used as a solution design, and then of course some future work. So as an introduction, the main goal of this talk is converting the human language to images, whereas the ability to convert a human language, we mean by human language any written script in English, where we can find this in different resources, in podcasts, in scripting for the videos, any type of video. We will convert it into structured data that can be translated to a graphical representation. Now we can see now the importance of large natural language models have been used everywhere, and the pre-trained models as well. So taking advantage of that with Python library, we can use it to convert the natural language to images. So the main technique that used for this work is a recurrent neural network, where it is a deep learning part and pre-trained models. We convert some available kids' stories to graphical representation, where the model has been trained based on that. Now, of course, as a related work, we do have a very main base for most interesting work has been presented. So the first reference in 2018, they introduced the attention generative network and designed it for detailed text to image creation. So they proposed a technique for a comprehensive attention-based multi-model similarity method to determine the image text matching when the training generated. This is the first reference. The second reference, like in their study, they introduced something called stack generative network, designed for creating 256 by 256 images based on the text description. Now the third related work, they present text conditions, classifier generative network, text to image generative network for generating images from text description. And then the last work that has been used here as a reference, reference number 4, same. So they're using these models, the deep learning models, were specifically for question answering. So in the last reference, in their work, they demonstrate the ability of AI agent performing video story question answer by learning from large amount of cartoon videos. So this is like a main, there is a lot of common work, of course, by different researchers, but this is the most common one that we use it for as a base for our technique. So the problem specification to design and implement system that can be used a large natural language models to convert the human language from text resources into structured data, and then this structured data can be transformed into graphical representation. So as an input and output, we do have source text data used in this experiment where the data used text files from children's story and from public available project, Gutenberg project. So to use the data to test and to train. And of course, we do have specific parameters that can guide this type of transformation has been used. The main output, whenever we read the text by the system, the text converted to visualization. We will see that in the result part. Now, of course, as mere requirement, we have a function requirement and non-function requirement. So as a pre-processing for our data, the text parsing, the data structure, and the graphical transformation, and then customization as well. Whereas the non-function, we can count that how effective our system is, the usability of the system, and other different non-function requirement. As a solution design, the main goal for this work is to design a system that can convert human language into structured language, which can be presented as an images, where as a technique, we used recurrent neural network, particularly long short-term memory model that can do this task. Now, as a main component of without any technical details, the main component that we use it here, text preprocessor, which is the technicalization of the sentences, parsing the sentences, clean up the text, and use specific models that build in Python. And then in second component, the RNN model, which is the recurrent neural network model, LSTM. We have layers that can be used as input layer, multiple layer, dense layer, and output layer, where the function, the activation function that has been used here as a ReLU function. And then the third step, which is the conversion of the output, which will convert the text for graphical rendering, and then the graphical representation, which is the final format, which is the image. Now, we have, as a part of the solution design, data collection, data pre-processing, the training, and the conversion to structured data, and generating the graphics. Again, if we wanted to go into the details of each and every step, there is a lot of models has been used as built-in models in Python that can take a while to be described in this talk. But as a general, like a description of the steps in the data collection, as I said, we use the text data, and it's from available online, like free data to train the model, and then cleaning this data to be used or prepared to be as an input for the model, and then the training, and then the conversion of this structured data, and then the representation of the graphical design. Now, as a general description of the main technique, the recurrent neural network, RNNs, where in any references, you can say that like we have the input layer, the output layer, and then hidden layers, where this hidden layers can represent the text data that we input to our model, to the RNN. And we can see here the attention model, which is the main for these large models. The reference for this diagram is attention all what you need, a paper that can give a detailed description of the diagram. Now, this diagram represents the transformer, the first sequence of the model based entirely on the attention. We are replacing the recurrent layers used in the encoding and decoding architecture with multi-headed self-attention. You can see here in this part, the right side part, where the input of the model in the left side, and this is the output. Now, all the mechanisms of how the transformers works, all the details in the paper. Now, as a conclusion of this model, we have been using the model or test the model um, to generate like a story for kids, where we have been developing short story as a complete book, where we tested the system using like a couple of sentences, right? And then by using these couple of sentences, the graphical representation will be presented. So you can see here, this is, we use it as an input, and as a sentence, as a text input, and then the output represented this this image. Now you can see here, it's a little bit longer story, has been used like sentence by sentence, and based on these sentences, the model generated different images. Now we preparing as like type of extended work for this. We preparing web-based, where the web-based will be used to generate storybooks based in these images. So for right now, we have a grant that will be used to generate this textbook, will help the student learn a different language. So this is the first version of the implementation of the model. So web-based to generate like images, where these images will be used as a story for kids. Now, the second implementation, or as an extended of this work, it will be using different language. So we know that like we have different like community here at the United States, and I'm volunteer in a school where the kids do not speak English. So we trying to generate some picture based in these images. So we will write the sentence in different language and in English language, and then generate the image. And then it is easy for the student to understand the representation or the meaning of these words through visual representation, where this is like the main goal of the project. It's education purpose. It is like a very benefit for a group of the students that struggling with a specific language. Sometimes will help them figure out the meaning of these words through visual representation. We know that like people have different learning ability, where specifically for the kids, they learn more with the visualization. So this was the main goal of creating this project. And this is like a first version, where we still extending the work for more idea. And of course, for like future direction, We wanted to improve the model. We're working in this side, even though the accuracy of the implementation for or generating of the image is perfect, but we still wanted to add more. Implement feedback loop where users can refine the graphics, and then feedback can be used to retrain the model for better result. Because for right now we're serving different people that they use these images to collect the data or the feedback and use it in the training part. Now, where we still have some challenging and consideration part where it is related to the technical aspect of this work. So, for example, making the system adopt different language, specifically for this one that we are working in it right now, because for right now, the system working perfectly with good accuracy for English language. Now, the next step, we're improving it to capture the Arabic language as well. And then different other challenging that we're considering to improve the accuracy for this system. Here is the references that we use mainly for the work, and thank you for your attention.